6 then, which is the binomial question on this paper. So what's going to change each time for this binomial question is the probability. The number, the n, is not going to change. So for part 1, we're looking for exactly 4 red loom bands. So the first thing I'm going to write down is that we have got the situation where x, our variable, is binomial. There are 50 trials and the probability of a red is 0.18. Okay, so this is A part 1, so let's just make sure that's really clear. A part 1, so that's the situation we're dealing in, and we are looking for the probability that our variable x is equal to 4. Now, exactly 4 red loom bands. So if I write out all this information, just makes it really clear what I'm doing to the examiner. So just going out of normal now, so we're doing distribution. This time we're doing binomial, so F5 binomial, and it's BPD, it's an exact value. Okay, so what we're going to then do, make sure this is set to variable. The exact value we're looking for, x, is 4, the number of trials, and I can just read this straight off this thing here. Okay, so the number of trials is 50, and my number of trials is 50, and my probability of success is 0.18. Okay, so the chance that there are exactly 4 red loom bands in this is 0.0262. Okay, so that's to 3 significant figures there, very unlikely. For part 2, we are still dealing with this variable x belonging to a binomial distribution of sample size 50, but now we're dealing with yellow. So the chance of getting yellow is 0.15, probability of yellow. We are looking for probability that this value of x is at most 10. Okay, so it is less than or equal to 10. Now, what I would encourage you to do, regardless of how good you are at spotting that, is to just potentially before getting to this stage, is drawing out this picture, which is involving the critical values. So the critical value in this case is the 10. That's the most important number in the question. So at most 10. So we want 7, we want 8, we want 9, we want 10. We don't want 11, we don't want 12. So we're dealing in this section here. Okay, so this is the section that x is less than or equal to 10. It's not less than or equal to 11, it's not less than or equal to 9. So we're going to change where we go to. This time we're doing distribution, binomial again, but now it's the continuous distribution. It's the less than or equal to. Our x value is 10, key value, 50 trials, but 0.15. So you need to make sure you're changing that each time. And that result comes to 0.880, to 3 significant figures there. And that again is just worth the next mark, and that's only worth 1 mark, that one. Moving on to part 3 then. This time we are looking for at least 30 blue or green loom bands. So x is now still belonging to binomial. There's still 50 trials, but now what's the probability of getting a green or a blue? So the blue is 0.25, the green is 0.25. So the probability of getting a green or a blue is those two added together. And identifying the 0.5 is the first mark of our 3-mark question. Now we're saying at least 30 blue or green. So again, I'm going to draw out my picture, just taking my key value, which in this question is 30, and just considering a few values around it. So at least 30. So not 28, not 29, 30, 31, 32. So I draw my box around where my crosses become ticks or my ticks become crosses. So I want 1 minus the probability x is less than or equal to 29. Because all that binomial CD, all the BCD actually calculates is less than or equal to. So we'll come back into here. This time my key value is 29, number of trials 50, and my probability is a half, 0.5. So working out what that is 0.8986. So for this question, it's 1 minus 0.8986. Okay, So I'm then going to use my other calculator just because it's quicker to calculate that probability. 0.101. And again, as I have been, just to 3 significant figures, my final answer there. So that was worth 3 marks. I'm just going to remove the workings to give us a bit more space before we have a look at part 4. So on to part 4. We are now looking for more than 35, fewer than 45 that are not yellow or white. So the probability yellow or white is calculated by adding together these two. So that's 0.2. So what we're looking for is our variable x, which is belonging to binomial. There are 50 trials and it's not yellow or white. So 0.8 is the probability that it's neither yellow nor white. You could work that out by just adding up those 4 numbers as well, not including the yellow one. We're then looking for more than 35 but fewer than 45. So again, critical values that we're looking for. So 34, 35, 36, all the way up to 44, 45, 46. So more than 35, not 34, not 35, more than 35. And fewer than 45. So 44 is fine, not 45, not 46. So then drawing my boxes where my ticks become crosses, I can see that I'm going to be doing the probability that x is less than or equal to 44, subtract the probability that x is less than or equal to 35. And I think that the picture is the best way of just spotting whether it's 44, 45 and 34, 35 in those situations. So going on to my calculator, then still set up from part 3, I want to change my probability to 0.8 and my x is going to be 2 different things. So let's do the 44 first. So the larger number should be 0.9519. Let's go 7, let's just go 5 so I don't have to do any strange rounding. And change the x value to 35. So I'm doing, and this should be a smaller number, so 0.06. So really unlikely that that's going to happen. So those are my 2 values. And again, just because it's quite quick, I'll use the other calculator and subtract 0.06072. So the probability that more than 35 but fewer than 45 are neither yellow or white is 0.891 to 3 significant figures. Okay, so I've worked out which values I'm interested in and done the probability that x is less than 44, subtract the probability that x is less than 35. Having a look at part B then, that's why the yellow section here is been pasted in. So this is from your formula book. Okay, so this is in the stats section of the formula book. The random variable r denotes red loom bands. So r is red loom bands that belong to the binomial distribution where there are 300 trials and we are looking for the probability that so probability of a red one, which from our table up here is 0.18. So we're asked to find the mean and the variance. So using the formula book for something of a binomial distribution, n 300 p 0.18, the mean is equal to np. So n times p, so that's 300 times by 0.18. And I'll just very quickly do that on our calculator. 300 times 0.18. So the mean is 54. Now the variance, that is this formula here. So that is np 1 minus p. So in this case, that is 300 times 0.18. And the thing in the bracket, 1 minus 0.18 is 0.82. Okay, so we're just multiplying that by 0.82. And that gives us the variance of 44.28. Incidentally, if we wanted the standard deviation, we would have to square root that variance. So if the question asks for the standard deviation, that would be 6.65. But for this case, because we asked for variance, we can just leave it as that. And so we've got 1 mark for the mean, 1 mark for the variance. So that question was just testing whether or not you knew your formulas or knew where they were in the formula book.